Hey y'all, welcome back. This is the second practice test that I've put together for students studying for the math portion of the TSIA2. It just has 20 sample questions that should be at least somewhat similar to what you can expect to see on the TSI. I'll provide a link down to my first practice test in the description, and I do plan on posting actually 2 more of these. I've got a total of 4 that I want to get up. So if you want just extra practice before you take the test, I think attempting all these questions will be decent practice. Really what you want to do is work all these problems on your own and then come back to this video and just kind of check the answers, and for ones you didn't know how to do or if you got it wrong, listen to the explanations, and hopefully you'll understand them a little bit better so that you can get them right next time. Your target for this test, it's hard to say exactly how many questions you need to get right because the test is prescriptive, meaning that the questions change depending on how you do, and not all the questions are weighted the same. So it's a little hard to say exactly how many questions you need to get right, but I think a good target is 12 out of 20. If you get 60% of the questions right, odds are you're probably going to pass. You might be borderline there depending on which questions you get right. But I think if you can consistently get 60% of these questions right and on the other practice tests as well, then you should feel pretty confident about passing the actual TSI test. So just like with the first practice test, I've got these questions sectioned off into the different categories of questions, with the first one being quantitative reasoning, the second one being algebraic reasoning, the third one being geometric and spatial reasoning, and the last one being probabilistic and statistical reasoning. So we've got 5 questions from each section here, and let's just go ahead and get started. Number 1 says, Olga has 6 bushels of wheat. She wants to pour all of the wheat into containers that each hold 1 peck. How many containers will she need? Now, one of the keys to getting this problem right is realizing that the containers she's pouring them into each hold 1 peck. So 1 container is essentially the same, holds the same amount as 1 peck. So we want to set up a proportion here. And if we know, and this information is going to be given to you because bushels and pecks are pretty obscure units of measurement. So I would be shocked if they do not give you this particular conversion here. Usually they're pretty good about giving you the conversions. But 1 bushel is 4 pecks. And what this question is asking is, if we've got 6 bushels of wheat, how many pecks is that? So we'll put X. Once you set up your proportion, we're going to use the cross products property. Sometimes you'll hear this called cross multiplication. And basically what it says is you can multiply one of the proportions numerator by the other ratio's denominator, and do that for both and set those 2 products equal to each other. So we'd have 1 times X equals 6 times 4, and 1 times X is just X, and 6 times 4 is 24. So with 6 bushels would be equivalent to 24 pecks. So our answer is A. Number 2 says a certain map has a scale in which 1/2 centimeter on the map represents an actual distance of 10 kilometers. Well, as soon as you get that conversion there, let's start writing our proportion, because it's going to be another proportion problem, and you're pretty much guaranteed to get at least 1 or 2 of these proportion problems on that test. So 1/2 centimeter on this map corresponds to 10 kilometers, and it says a distance of X kilometers is represented by how many centimeters on this map. Now, this question is a little tricky because you're not actually solving for X. You're solving for the number of centimeters in terms of X, and they don't give you a variable to represent that. So I'm just going to put a little question mark box here. Say it's that many centimeters as a reminder to myself that that is what I'm searching for. Now, the setup will be very similar to number 1, where we'll use the cross products property again. We'll cross multiply, or I've heard some middle school teachers call this the butterfly method, which I kind of like. But either way, we're going to multiply this question mark box by 10. So 10 times the number of centimeters equals 1/2 times X. And if we're solving for that little question mark box, we need to divide both sides by 10. So 1/2 divided by 10, and this is something that you could do in the calculator, but that is 1/20. So this is going to equal 1/20 times x, and 1/20 times x is equivalent to x divided by 20. And so our answer is A. Number 30 says Robbie bought 7 pencils from a bookstore. Some of the pencils cost $3 each, some expensive pencils. The rest cost $4 each. Geez, these are some fancy pencils, some Ticonderoga or whatever they're called. If she paid a total of $23 for the pencils, how many of the $3 pencils did she buy? Now, we could set this up like a system of equations where $3 pencils, which I'll call X, plus $4 for the fancier pencils, which I'll call Y, equals 23. And we know the total has got to add up to 7 because she bought 7 pencils. You could solve this like a system, and I'll go through that algebra quickly with you. But honestly, I think this problem is going to be a lot easier if we just take advantage of the fact that it's multiple choice. So if the question's asking for the number of 3 pencils she bought, these answer choices are for the number of $3 pencils, right? And if we know that there's a total of 7, we could also fill this out for the $4 pencils, right? Because if there's 2 of the $3 pencils, there would have to be 5 of the $4 pencils because there's a total of 7. If there's 3 $3 pencils, then there's 4 $4 pencils. If there's 4 $3 pencils, there's 3 $4 pencils. I feel like saying this out loud, this sounds really weird, but okay. So if there's 5 $3 pencils, there are 2 $4 pencils. Basically, like these have got to add up to 7 because there's a total of 7 pencils being bought. So once we come up with these combinations, we can take each of these pairs, so like 2 $3 pencils and 5 $4 pencils, and test them in this equation here. Basically, plug in your X, plug in your Y, and see which one works. So I'm going to go through A through D and see if we can't figure out which one works. So for choice A, we've got 2 $3 pencils and 5 $4 pencils. And if I do 3 times 2 plus 4 times 5, this is something you'd want to do in the calculator, you get 26. Now, that's not what we're looking for. We want the total cost to be $23. So it's not going to be A. Okay, choice B says that there's 3 of the $3 pencils and 4 of the $4 pencils. 9 and 16 is 25. Again, this is not going to be correct, so the answer can't be B. 3 times 4 plus 4 times 3 is going to be 24. You might be noticing a pattern here with these answer choices, and that pattern is going to continue. So it's not going to be C. D, 3 times 4 plus 4 times 2. Oh, sorry, that should be 3 times 5. Is going to be 15 and 8, which does equal the $23 we're looking for. So our answer here is D. Now, going through the answer choices is a solid strategy, especially if you know your algebra is a little shaky. But it's also good if you know like how to solve this sort of the traditional, the proper way. And I do want to show you how that's done. There's not a ton of room here, so I guess what I'll do is I'll just kind of work it to the side here. I'll zoom in and I'm just going to go through the algebraic steps here. So if you have 3x plus 4y equals 23, and another equation that's x plus y equals 7, the way to solve a system of equations is going to be to try to plug one equation into the other. And so if x plus y equals 7, if I say subtract x on both sides, I'm going to get y equals 7 minus x. And if y equals 7 minus x, I can substitute that expression into y for the other equation. Okay, so I can rewrite that as 3 times x plus 4 times 7 minus x, and then solve this equation. And when I go through and I solve this equation, you're going to get, I'm going to skip all the algebra here, but you're going to get x equals 5, which is going to give you your answer. I'm just kind of running out of room here, but basically you'd use the distributive property, you'd combine like terms, and then use your properties of equality to simplify that answer. I think this is honestly way easier to just go through the answer choices and check which one is correct. That's the way I would advise you to do it. But if your algebra is on point, you can solve it this way, just sort of directly. Okay, let's move on to number 4. Let's see, I just want to delete all this. Okay, number 4 says, if the price of 7 bananas is $1.12, what's the price of 18 bananas? Now this is one where we could set up a proportion like we did on number 1 and number 2. We could, say that 7 bananas corresponds to $1.12. So what is the cost of 18 bananas? And you could cross multiply and solve this, but I think it's actually easier when you're just trying to figure out how much a different group of bananas are, is to just find the cost of a single banana and then multiply it by 18. And that's essentially what you're doing here. I just think conceptually it's a little easier to kind of process through your head rather than coming up with a proportion, using cross multiplication and solving it. So let's just find first the price per banana. So the price for one banana is $1.12 divided by 7, right? Because 7 of them is $1.12. So this is something we'll throw in the calculator, okay? And that's going to end up being 16 cents. So now we know how much one banana is. So the price for 18 bananas is going to be that 16 cents times 18. I'm going to type this in the calculator over here. I get 288. So the answer is B. There are exactly 40 toys in a box. So we're starting with 40. If X toys are removed, so we're going to subtract X, which of the following expressions represents the number of toys left in the box? So that's basically it. There's no algebra or arithmetic here. It's just a matter of setting this up correctly. And the only real tricky part here is knowing that you're subtracting the X from 40 rather than the other way around. So just be careful of that. But otherwise, this one should be a pretty easy one to get right. Okay, let's go move on from the quantitative reasoning to algebraic reasoning, where we're going to be solving equations, doing a little factoring, that sort of thing. So number 6 says if 4x plus 7 equals 10, what is the value of x? So if I have 4x plus 7 equals 10, I can subtract 7 on both sides. That's going to give me 4x equals 3. And then I can divide both sides by 4 to get x equals 3/4. And that is your answer. You're just using those properties of equality to solve that two-step equation. Number 7 looks a little bit more complicated. There's a little bit more going on with this equation, but we're still going to be using our properties of equality. And let's just see what happens here. So first, I'm going to distribute this minus sign and rewrite this as 3a plus b plus 4 minus b minus 6 is 14 plus a. Now I want to try to combine my like terms on either side of the equal sign. So I'm going to be looking for a's to put together, b's to put together, and also my constants to put together. Now I only have a single a term on the left-hand side here, so that's just going to remain 3a. Then I'm going to combine my b's. So notice here I've got b minus b. Those are going to cancel each other out. B minus b is 0, so the b's go away. And then I've got plus 4 minus 6. That's going to be minus 2. So I get 3a minus 2 equals 14 plus a. And now I need to isolate a. There's going to be 2 steps here, but we can do them all together since they don't affect each other. And that is we want to move our constants to the right and our variables to the left. So to move the variables to the left, I want to subtract a from both sides to get rid of it over here on the right-hand side. And to move this 2 over to the right, I'm going to add 2 to both sides. And that'll effectively get rid of that. Okay, so 3a minus a is going to be 2a. The negative 2 plus 2 zeroes out, which is intentional. 14 plus 2 is 16, and then the a zero out over on the right. So we have 2a equals 16. If I divide both sides by 2, I'm going to end up with a equals 8. Our answer is B. Number 8 says, which of the following is not equivalent to 24b minus 12? Now, you could try to factor this, but there's going to be a little bit of factoring it kind of different ways. I think the easiest way to accomplish this one when you're looking for an equivalency is just to pick a simple value for x and substitute. Okay, so well, I guess in this case it's b, not x. But basically, whatever the variable is, just pick a number. I'm going to start with like b equals 1. And I'm going to substitute that in to the original expression and then each answer choice and see which one is not the same. So if I plug in 1, I get 24 minus 12. And so 24 times 1 minus 12 is going to be 12. And so I'll go through and I'll plug in 1 into A, B, C, and D, and hopefully one of these will not equal 12. So if I plug in, so basically I'm going to plug in 1 here, 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 and here. Okay, so 12 minus 12 is 0. 0 times 2 is 0. So it looks like our answer is probably going to be 8, right? Right away. But let's check the rest. 12 minus 6 is 6. 6 times 2 is 12. Okay. 6 minus 3 is 3. 3 times 4 is 12. 2 minus 1 is 1, and 1 times 12 is 12. So the only one that doesn't equal is A, and so that's going to be our answer. You could also do that for number 9. In fact, anytime you're just comparing two expressions on a multiple choice test, just pick a number, plug it in. We can use that strategy here. Like if I just plug in 1 again, so I have 1 squared plus 3 times 1, that's going to be 1 plus 3 is 4. 4 minus 10 is going to be negative 6. So whichever one of these equals negative 6, if I plug in 1, should be my answer. So I'm going to just plug in 1 everywhere. So here I've got negative 4 times, what was that, negative 1. And that would be positive 4, so it's not going to be A. Here we've got 6 times 3, which is 18. We're looking for negative 6. Then we've got negative 4 times 3, that's negative 12. So hopefully D is correct. And here we got 6 times negative 1, which sure enough is negative 6. Number 10, if g of x is 10 to the x power, then for what value of x does g of x equal 10 million? So in other words, 10 to what power is 10 million? So the trick here with powers of 10 is that whatever the exponent is here will correlate to how many zeros are in your number. So here we've got 1, 2, 3, 4, 5, 6, 7 zeros. So yeah, it's going to be 10 to the 7th power is 10 million. And that about does it for the algebra section. Let's move on to geometry. Number 11 says a restaurant is building a rectangular deck around a rectangular bench. According to the diagram below, which is the area of the deck is not covered by the bench? So this is one of our frame problems where we take the area of the, so the total area that we're interested in is, let me just highlight it, is this area around the bench. And so anytime you have the area of a shape with a shape like taken out of it, the total area is going to be the area of the big shape minus the area of the shape that's on the inside. Okay, now both of these are rectangles, so the area formula is just base times height. The area of the big shape here is 12 times 6. The area of the small shape is 2 times 8. And so we get, let's see, 12 times 6 is, that would be, gosh, sorry guys, 72, there we go, minus 16 is going to be 56. So 56 square feet. Number 12 says Tim has a square table. So let me go ahead and sketch this out. Square table with side length of 6 feet. That is an awful square. Let me try that again. It's not much better, but we'll just label it. So it's a 6 by 6 table. He can enlarge it to a rectangular table, which increases the length by 3 feet. So, okay, here we're going to increase the length by 3 feet. Oh, but also the width by 2 feet. So we need to bring this out 2 more feet and bring this out 3 feet. Okay, so it says, how much bigger in square feet will the new table be compared to the old table? So what we need to do is find the area of the old table, the area of the new table, and then subtract them. So the area of the small table, the old table, is going to be 6 times 6, which is 36. The area of the new, the bigger table, is going to be 9 times 8. So be careful here. It is 9 times 8, which is 72. And so the difference will be 72 minus 36, which is 36 square feet. Number 13 says if the length of a rectangle is, so the length is means equals, 4 less than means we're going to have a minus 4. The 4 less than is always kind of the tricky thing because it's going to like be written backwards in the actual equation. Twice the width W, which is 2W. It's just asking you to write that equation so you don't have to actually do anything with it. Our answer is going to be B. Number 14 says a square has an area of 49 square centimeters. So if the area is 49 square centimeters, and this is a square where the side lengths are the same, the sides have to be 7 by 7. And if it's asking for the perimeter, that is all the sides added together. So the perimeter is going to be 7 plus 7 plus 7 plus 7, because all the sides are the same. So you just add up 7 4 times, or you could just do 4 times 7. Either way is fine. You're going to get 28 either way. So our answer is A. Number 15. A rectangular swimming pool is X yard wide. I'm going to go ahead and actually sketch this out. X yards wide. The length of the swimming pool is twice as long as the width, so that'd be 2x. If the perimeter of the pool, so that's all the sides added together, is 128, which of the following equations represents the information? So we've got 2 side lengths that are x, 2 side lengths that are 2x, and if we add up all 4 sides, we get 128. So that's really what we're looking for in the equation. We've got x plus 2x plus 2x equals 128. All that checks out, and our answer is A. Okay, that's enough geometry for this practice test. Let's do a little probabilistic and statistical reasoning. And a lot of this has to do with just knowing what the important words mean. Like number 16 says the following are scores for 5 students in Miss Goldman's history class. What is the range of the scores? So here it's a really easy problem if you know that range is the maximum minus the minimum. So it's the difference between the biggest number and the smallest number. Now, if you don't know what range is, then this question just becomes like a guess. But if you do know what it means, then it's really not that hard because you're just going to subtract the biggest number, which in this case is 776, minus the smallest number, which in this case is 399. And this is something that you would put in the calculator. So we get 377, and our answer is C. Number 17 says students in Miss Frost's science class use scales to measure the mass in grams of a solid. The mass of the solid was reported as 4.2 grams, 4.8 grams, 5.2 grams. Okay, so we got a bunch of measurements of the same solid. I don't know if these students know what they're doing or why they're so different, but for whatever reason, they all got different measurements. And the question is asking which measure would be the best estimate for the actual mass of the solid. Well, really what we would do is just find the average of all of these, and that will probably be the best estimate. And the average is the mean of that set of data. The minimum is the smallest one. And, what are the odds that the smallest measurement is actually the true measurement? Probably not. The maximum, that's the biggest one. Okay, so again, the biggest measurement here, probably not going to be the true mass. The mode is the most common measurement. And here, actually, none of the measurements are repeated, so there is no mode anyway. So the only possible answer here would be D. Number 18 says the distance that Kim walked for each of 5 days is shown in the table. What is the average distance that Kim walked per day? The average, another word for that is mean. So if you see the word mean, it means average. And the way you calculate average is by adding up all your data and dividing by how many data points you have. So the average here will equal 4 plus 5 plus 3 plus 6 plus 6 divided by the number of data points we have, which is 5, right? 1, 2, 3, 4, 5. And so we'll just put this in the calculator. So yeah, 4 plus 5 plus 3 plus 6 plus 6 is 24. So this is going to be 24 divided by 5, and we get 4.8. So the answer is B. Number 19 says the circle graph gives the distribution of drinks by customers at a restaurant. If approximately 200 customers order a drink each day at the restaurant, which of the following is closest to the difference per day between the number who choose coffee and the number who choose water? So we really only care about coffee and water here. And what we need to do is figure out how many people actually ordered each one of these. So to figure out that number, you're going to multiply the percent by the total. So if 45% of people chose water, we're going to multiply 0.45 times 200 for the 200 customers, and 0.45 times 200 is 90. So 90 people ordered water, and we'll do a similar calculation to find how many people ordered coffee. 0.3 times 200. So 0.3 times 200, let's see, is 60. So this is asking about the difference. So the difference is going to be 90 minus 60, which is 30. So in other words, 30 more people drank water versus drank coffee. And that takes us to our last problem, where we've got this bar graph that we need to interpret. It says the number of books sold per month by 3 salespeople for 4 different months is shown on the given graph. Based on the graph, which of the following is a true statement? And all of these statements have to do with the average number of books sold by the 3 salespeople every month. So let's go through and actually calculate the averages. For January, we'll do like 40 plus 40 plus 70. So I'll just write this one out as an example. 40 plus 40 plus 70 divided by 3. Now let's go ahead and calculate that. 40 plus 40 is 80 plus 70 would be 150 divided by 3. So the average in January was 50 books sold. And we want to calculate the average for all 4 of these months. So in February, we've got 20 plus 60 plus 40. And we're going to divide that by 3 to get an average of 40. We'll do the same thing for March. We have 30 plus 50 plus 40, all divided by 3 is 40 again. And then lastly, for April, we've got 50 plus 60 plus 70. And that's 180 divided by 3 is 60. So now we know the average number of books sold by the 3 salespeople in each month, so we can answer the question. A says the average number of books sold in April was 60, and that looks right. So our answer is probably going to be A here. But let's double check the rest of these. It says in January the average was 60. That's not right. We can see that it's 50. It says in February the average was 50. Again, that's not right. We can see it's 40. And D says the average in March was greater than the average in February. Well, March and February had the same average, so that can't be right either. So the answer is for sure A. And that wraps it up for this practice test. Hopefully you guys are getting enough practice here so that you can be successful and pass that TSI. But if you feel like you need a little bit more practice, I will be posting a couple more of these practice tests. So other than that, you guys have a great day, and I'll see you next time.